So on the screen we have Vivian, Samantha, and Brenda. So they're finalizing this. Vivian, can you share with us what the question was asking?
Yes, they're asking us to find the sum of this. And so since we see that it has the same denominator, we can split it up into two fractions. This one and that one, but we can see that they're all, like 1/3 to the n is a geometric series. So we know that since r is the absolute value of 1/3, it converges.
Okay, so the question wants us to find the sum for that series?
Yes.
Okay, right.
And so in the second part of when we split it up, the r is 2/3, which is also less than 1, so it converges. And so since they both converge, we can use this formula a over 1 minus r to find the sum of this one part, and then a over 1 minus r to find the sum of the second part, and we find the total sum is 9 times.
And because a of n and b sub n converge, that means that the original equation also converges.
So one last question. When you look at this problem, which part of it you think would be most challenging for other students?
Figuring out like split it. Yes.
Split into two?
And then making this connection that the 1/3 to the n power can actually be 1/3 to the n.
Because once you have that, you can figure out that you can actually fit into this equation.
Very good. Thank you. All right, gentlemen, tell us what the question was asking.
Okay, so the question is, it tells us to find the indefinite integral of the square root of 1 plus cosine of x with respect to x.
And the way that we started approaching this was we used the half angle, or the power reduction formula. So we said cosine squared of u equals 1 plus cosine of 2u divided by 2. And then from there we let u equal x over 2. And it works out so that we get, on that side, the number of radicals.
Yeah, the argument for the radical.
Argument.
Very nice, yeah.
So then, all we did was then plug this in. So this square root gets rid of the square on top of this cosine squared here. And the 2 just becomes a square root of 2.
Okay.
From which point we can just integrate normally with sine of x over 2.
So let me ask you this. So when you look at this problem, which part of this problem you think would give the most hard time to other students?
It's definitely just getting started from the beginning. It's figuring out what to put under the radical and what to substitute.
Yeah, because I noticed earlier you had a good discussion among you, and you were going back and forth. Very good.
Yeah.
All right, thank you.
Thank you.
The stage is yours.
Okay, hi, this is Calc 2, and we were testing our series to see if it was convergent or divergent. So we did the integral test. So essentially what I did was take the limit. How should I explain this, Sean? All right, so what I did was I turned my series into a definite interval, and because the bound's infinity to 1, I changed this to b, and I integrated, and I got the limit as b approaches infinity to 5n 4/5 over 5. And I took the fundamental theorem of calculus, and this, when I plugged in infinity, I got infinity, and this was so small compared to infinity that it really didn't matter. So my integral converged because it's infinity, which means
Diverge.
diverged is what I meant to say. Woo!
Very good. Very good, thank you.
Yes.
So I had to do the integral test as well. So I took the limit as b approaches infinity of 1 over x to the 5th, changing this to my function x. And then I got x to the negative 5, I just brought it up to the numerator. To make it easier to integrate, I get x to the negative 4 over negative 4, which I then changed to negative 1/4 x to the 4th. To further simplify it, when you plug infinity in for b, you get 1 over infinity, which gives you 0, double negative 1/4. So you end up getting positive 1/4. And because my integral converged to 1/4, I know my series will converge.
Thank you.